Welcome to all of you. In this session, we are going to understand the Scilab program for the development of DIT FFT algorithm without using the inbuilt function. First, let us understand the theory of the decimation in time FFT. So, we are going to consider the 4-point DIT FFT butterfly diagram for this one, and this is how the 4-point butterfly diagram looks like. It is observable that the input is the time domain, output is the frequency domain. The input is not in a sequence, whereas output is in sequence. So we are going to have two stages of calculation. So this is the first stage of calculation and this is the second stage of calculation. So after second stage we are going to get the final answer. So it has to be taken stage by stage only. Now here is the stage by stage representation of the equations we are going to have. See, for a of 0 we are going to have the x of 0 which is on the line itself, and then x of 2 multiplied with this dual factor added with this one. So that's why a of 0 is x of 0 plus omega 4 power 0 into x of 2. So similarly it has been taken for a of 1, then b of 0 and b of 1. So once we calculate this stage of the result, then this will be used to calculate the next stage of the result. Similarly, it has been written. So x of 0 is equal to a of 0 plus omega 4 power 0 b of 0. Similarly, it is done for x of 1, x of 2 and x of 3, and this is going to be the final answer of 4-point DIT FFT. Let us consider an example for this one. Compute 4-point DFT of the sequence x of n equals 1010 using DIT FFT radix-2 algorithm. Same diagram is being given over here, and then based on these expressions we are going to have the substitutions and we are going to have the result stage by stage. So this is the first stage of the result and this is the second stage of the result. Second stage of the result is the final answer. Now we are going to make use of the same expressions in order to write program for DIT FFT algorithm using Scilab. See, we are going to have two methods actually. FFT function is also available, but in this particular case, so it is clearly mentioned not to use the FFT function. Therefore, we are going to make use of these expressions stage by stage, and we are going to identify the FFT of the given sequence, and we are limiting the program also for 4 points only. Now let us go through the Scilab program for this one. So starting, we are going to consider what value, for which value we need to identify the FFT, then number of points, then we are going to define the twiddle factor, and the j is going to have the value square root of -1, and we are going to have two twiddle factor values omega 4 power 0 and omega 4 power 1. So omega 4 power 0 is taken as w0 and that will be 1. Omega 4 power 1 is taken as minus j and represented as w1. That will be used further. For the first stage of the result, a and b are the two parameters which we observed in the diagram. Same parameters are being used here also. So a is going to have a of 1 and a of 2, b is going to have b of 1 and b of 2. Remember, while showing in the diagram, we took it as a of 0 and a of 1. But in Scilab, we cannot have a of 0. Therefore, we are going to take a of 0 as a of 1 over here, and a of 1 of the diagram will be a of 2 over here. So that is what the consideration we have to take over here. So these four statements belongs to the first stage of calculation. This will be continued for the second stage, and these four statements corresponds to the second stage of calculation. And after the second stage we are going to have a display of those values calculated, and again we need to make an observation that what has been calculated without using the FFT function is same as what we get from using the FFT function. Therefore, we are also making use of the FFT function and calculating and displaying both that has been calculated for comparison. Now let us have a simulation of this one. Now here we can observe the values. See, without using the function, inbuilt function, this is what the result what we have got. And by using the inbuilt function, this is what the result we have got. And both of them are going to provide us the same answer. So that's why at the last we are having this one. So without using the inbuilt function, the first answer, and then the second one is what has been highlighted with using the FFT. Now let us have one more example where we are going to have the complex values as the result. So I will take 2, 4, 6 and 8. Now running this content. So we are going to have the representation. So we can make an observation. So first value 20, 20. Second minus 4 plus 4i, minus 4 plus 4i, minus 4, this is minus 4, then minus 4, minus 4i, so minus 4, minus 4i. So this answer is without using the inbuilt function, and this one is using the inbuilt function. Both of them are the same answers. Thanks for watching.